Maritime Made is sponsored by Invest Nova Scotia because great things are happening. Invest Nova Scotia connects your business with the right resources and opportunities. InvestNovaScotia.ca.
Enginuity is an innovative engineering firm based in Spryfield, Nova Scotia. They create their own products, but they also help other companies find creative engineering solutions to problems in their own businesses. Their team includes talented and creative engineers, designers, technologists, researchers, and strategists. And together, they tackle complex problems with fit-for-purpose solutions.
Enginuity is a creative engineering solutions company. We're all about demystifying some of the stranger parts of engineering, helping our clients find solutions to challenging problems, and generally moving the needle for our clients. Solving technically challenging problems, bringing a multidisciplinary team to the table to holistically look at all of the potential solutions, see what's available in different industries, put them together, and innovate using our own imagination and curiosity.
Everything they make goes through their design control process. Each project begins with a discovery meeting where the Enginuity Inc. team comes together to explore the challenge, the customer, and the potential workload involved to find a solution to the client issue. Enginuity uses this meeting to gather clients' ideas, understand what they need to do, and what is currently preventing them from getting there. This meeting then creates the rest of Enginuity's work plan. Conceptual design takes the initial set of ideas and imagines them into what could be. Here, a prototype piece of their own FIVA medical device is mocked up using a 3D printer. This device was created to alert medical professionals when anesthesia delivered by IV saline bags run dry. This is called fused deposition modeling. A nozzle adds the material on in layers. The 3D printer allows them to test functions, do concept development, and to print full housing for rapid prototyping of parts before designs are injection molded. It's also used to create custom tools for other assemblies. Preliminary design can include making various prototypes. Here's a product they're developing for a company called Clean Bands, wristbands for those handling food to remind them to wash their hands. Sketched concepts of the external design shape are being made with Adobe Illustrator. A variety of ideas are designed and prototyped to see what the client prefers. From here, the preliminary design review happens with preliminary prototyping. Details of internal parts are added to the design. The automation and robotics department plays a big part in the preliminary design review. This high-speed pick-and-place Delta Spider robot is programmed. It picks up white balls, placing them according to the coding. It runs off 3 electric motors and 3 knuckles, and can work in a 1 meter by 1 meter and 30 centimeter tall range of work. This versatile 6-axis industrial robot can be programmed with this smart pendant to pick, move, and place something to any location at a very high speed. Its end-of-arm tool can be manufactured for particular jobs and can include suction cups such as these to hold boxes, or gentle or hard clamps as examples instead. It's able to handle 12-kilogram maximum payloads. It can be used to sort different colors or sizes of products. This larger machine has more safety features, such as a camera monitoring close movement that would slow the machine down or make it stop. Physical barriers prevent interruptions.
The company slowly grew. Before we knew it, we were in industrial manufacturing plants. We were doing product design for people. We did a series of medical devices, including our own FIVA Flow here, which has been very successful. And so we've slowly evolved into these sort of verticals of our own, of groups of product design, controls and automation, mechanical design, electronics design. It's been a natural evolution, really. And now we're working across the globe, really, on contracts all over the place. So we've kind of broadened it out a little bit, and we want to make sure that what we do means something.
Design reviews include fully detailed designs and fabrication packages, which lead to manufacturing approval. To demonstrate, female receiver plates for Enginuity Inc.'s own product, the Sealift, which is a redeployable offshore connector, are being fabricated. This is the part that attaches to million-dollar assets deployed into the ocean and also retrieves them safely. It's being sawed out of stainless steel. Water-soluble oil flushes out the chips and keeps the blade cool. Once cut, this bar stock has the inner slope of the receiver plate lathed. It's sawed again with a rough saw and placed in the soft jaws of a chuck before it's turned on the lathe. It's faced next to make a uniform piece. Fixtures are drilled and bored here. Finally, cross holes or mooring connections are made by the mill. The male part of the Sealift is assembled. Loctite is applied, followed by silver-grade anti-seize. Screws and bolt pins are inserted. The sliding plate is added, followed by a spring and more Loctite, and finally the pad eye. This is how the male and female pieces of the Sealift work together. Another local startup, Lorax, invented a product that automatically controls gas valves for gas utility outlets all over North America, and their product is Enginuity designed. Here, they're testing how the printed circuit board inside works at different temperatures, in this case, minus 30 degrees Celsius. This battery-powered device can cut off gas during disasters. A screw is removed to let the mineral oil protecting the electronics out. Bolts are removed to take the back of the clamshell case off, to take the circuit board out and test it. The PCBs are built and tested in their electronics lab. The circuits from Lorax are tested to ensure peak performance. The ground connection and continuity are checked. Enginuity's own product, the FIVA, is also built. Once bolts and batteries are secured, it's tested to ensure its functionality works with dripping sensors activated or deactivated. This is their C-Snap device, a better marine carabiner with dynamic load capacity that snaps and releases.
At its core, we do what we do because it's a lot of fun and interesting, and we love to see, the impact. It's busy. It's got this wide range of successes. You pick an industry and I'll find something in it that we've done. It's hard to say. And we've had some misses too. It's not all success, but just the diversity and the breadth of those challenges that are all somewhat technical in nature, they require such kind of just an open-minded, okay, how are we going to, where does this fall and what have we seen? That's really the most interesting thing.